So for the final video of this lab, we're going to look at how you actually define matrices within MATLAB. So much like we did with vectors, we're going to start by actually defining them on an element-wise basis, which means we're going to key in each of the elements within a matrix. So I'm going to clear out my command window with the CLC command. I'm also going to clear out my workspace with clear all. And then what I'm going to do is show you how you define a basic matrix. So the key is that matrices are defined on a row-wise basis in MATLAB. So if I have a variable A and I want to define, say, a 2 by 2 matrix, and say I'm going to make the elements 1, 2 in the first row and 3, 4 in the second row, what you do is you pretend you're just generating a row vector for the first row, so 1, 2. And then you tell MATLAB that you want to go to a new row by using the semicolon. So if you think about it, row allows you, the comma rather, allows you to move within a single row. The semicolon allows you to move to a new row. And each time you're going to start back in that first column. So the elements by default are going to start in the upper left-hand corner. So 1 will be in the element number 1, 1. When I see that comma, I'm going to go over to the second column. So that will be the element in 1, 2. And then if I want to generate the second row, 3, 4, I again use a comma in order to delimit. So you see the commas kind of separate elements that are within the same row, and the semicolon allows us to start a new row. So if I don't terminate that with a semicolon and I hit enter, we will see that I have a 2 by 2 matrix. So what I'd like you to do is kind of use that same ideal in order to show me the syntax required to generate this matrix here. And one thing I should have said a little bit earlier, and I believe it was in the notes, is that variable names within MATLAB are case sensitive. So make sure to use the capital A. The capital A does matter. Notice I could have, I already have lowercase a defined as this 2 by 2 matrix. I could define capital A as a scalar, and these aren't the same things. They're actually stored differently within my memory there. So make sure to be careful with your case and generate this 1, 2, 3 row by 1, 2 column matrix in MATLAB. So show me how to do that. Now, the other thing that I want to talk to you about is the basic ideas of concatenating matrices or vectors within MATLAB. So what do I mean by concatenating? Well, if you think about it, let me actually show you this. Say that I had 2 row vectors. Say A is 1, 2, and B is, and I should be terminating these with semicolons, that way I don't muddy up my workspace, but 3, 4. What do you think would happen if I defined a new variable C? And the way that I did it is I created a matrix and I referenced A. Remember, A is an actual row vector. And then I put a semicolon, and then I referenced B. What do you think would happen there, right? Remember that a semicolon basically says go to a new row. So what I would be doing is I would have A, which is a row vector, 1 by 2. And I would have a semicolon, which says go to a new row. And then it would try to put B in there, which is 1 by 2 as well. Well, let's see what happens if we just execute this command. If you notice, we get a matrix where the first row is nothing more than A, and the second row is nothing more than B. And this is the basic idea of actually concatenating, in this case, vectors in order to create a matrix. So I could do the same thing. I don't necessarily have to concatenate vertically. That's what we did there. We stacked 2 things vertically on top of one another. I can also concatenate horizontally. Now let me show you what I mean by that. So say I had 2 column vectors in this case. Remember that in order to generate column vectors, you use semicolons as your delimiter. So say 1, 2, 3. Let's just see how that would look. And then say B was 4, 5, 6. Let's see how that would look. If I create a new matrix and put those 2 things together, now remember, these are both vertical. So you got like a 1 by 3 and a 1 by 3. So how would it make sense to concatenate them? Well, there's a couple different ways you could do it. Say we did it the same way that we did previously. And I just put A comma B. I'm sorry about that. A semicolon B is what we did previously. Remember that semicolon, in the last case, it actually took a row and it put it on top of a row. I call that vertical concatenation. So what do you think is going to happen if you have a column and you vertically concatenate it with a column? So remember that this is 3 by 1, 3 rows, 1 column. This is 3 by 1. And if you vertically concatenate those things, it's probably not surprising to you that you're going to get something that's 6 by 1. So when you're thinking about concatenation, that perspective of the delimiters, the comma, and the semicolon, remember that what the semicolon does is it allows you to concatenate vertically. If I were to define another matrix that was nothing more than concatenating A and B with a comma, in that case, I'm not going to concatenate vertically, but I'm going to concatenate horizontally. So if you think about it, you have a 3 by 1. If you concatenate horizontally with another 3 by 1, you're going to generate something that has 2 columns. It's 3 by 2. So what I'd like you to do for this last portion of the lab is just show me a screenshot of how you could make A as the concatenation of those 2 column vectors. And remember that in order to do that concatenation, you're going to need to concatenate in the horizontal direction, and the way you do that is with a comma. Now, we'll talk more in detail as we go on in the course about whether or not you can always concatenate things, what consequences might arise from trying to concatenate things that don't work. However, just know that that is how you do the basics of concatenation, and that this is the end of our first lab. So really what I wanted you to do is just get a little bit of experience actually executing commands on the command line in MATLAB that involve basic matrices and vectors, and really just give you a chance to get an assignment in that involved the basics of coding. And it's easy to say, well, we kind of use MATLAB, the application, as a calculator. We didn't do any coding, but we in fact did, right? We talked about the basic principles of variables, the syntax for defining a variable, the syntax for valid variable names, the idea of the assignment operator, and so on. In addition, we talked about a lot of commands and utilizations of the user interface within MATLAB to actually use the application, in this case, the cloud application, as an integrated development environment. And as you code, right, really what makes people excellent coders as you move on is not that they have all this syntax committed to memory. It's that they have the capability to locate the syntax that they need using web tools, and that they are very good at using whatever integrated development environment they need. Because what coding ultimately boils down to is being typically the way the workflow works is you identify a code base, usually on GitHub, that does something similar to what you want to do. You make a copy of that. I won't use the GitHub terminology for now. You make modifications in order to make it fit your need, and undoubtedly the modifications you make aren't going to work. And you're going to have syntax errors, and you're going to have to track those down and be able to fix them. That debugging process is heavily dependent upon being able to use your integrated development environment. So when you hear the term IDE, that's what that means, and that's why we start with MATLAB. Because in a lot of programming languages, remember MATLAB is both an application and a programming language. They build the integrated development environment for you. You don't have to pick which tool chain you're going to use, which particular text editor that's going to have these nice adaptive features that allow you to know whether you're committing syntax violations or allow you to autocomplete and so on. All of that is kind of hidden for you because the programming language and the integrated development environment are coupled. So I will see you all in another lab later this week, along with some actual lectures. I'll talk to you all soon.